Okay, so for this next proof, I'm going to be proving that the derivative with respect to x of e to the x is e to the x. Okay? Now I'm not going to use the limit definition to prove this proof. I'm going to use something else a little bit different. But it works out simply and wonderfully, and it just uses all the other things that we've already proven. So we're going to go ahead and approach it in this direction here. Now, the first thing you start off with is a basic log property. Now, I'm not going to call this a background, even though it kind of is, but it's because it's the first step of our proof, and it's just going to be there anyway. Now, the first thing we're going to start off with is the fact that the natural log of e to the x is x. Okay. Now, what I'm going to do is I'm going to do some differentiation here. I'm going to take the derivative with respect to x on both sides. Now the derivative of x with respect to x is just 1. Okay. Over here we have a chain rule. Okay, I've got my outer function, which is ln. I've got my inner function, which is e to the x. Okay. So the derivative of ln is 1 over the inside, so in this case, e to the x, times the derivative of the inside. Now, a lot of you guys are probably thinking, well, the derivative of the inside, well, that's e to the x. The derivative of e to the x is e to the x. We can't assume that the derivative of e to the x is e to the x, because that's what I'm trying to prove. You can't use what you're trying to prove it, right? So what I'm going to do is I'm going to put this expression instead. The derivative of e to the x will be written like this. So this represents the unknown derivative of e to the x. We really know it's e to the x, but right now we're pretending that we don't. So so 1 over e to the x times the derivative of e to the x is 1. Well, if you multiply both sides by e to the x, this one will cancel out, and you end up with this. So there's your proof. The derivative with respect to x of e to the x is itself. So I like that proof. It's nice and simple and clean. So we could probably also do a limit definition one, but I think I'm going to leave it at this. So.